Good day, ladies and gentlemen. Today we're going to do Unit 0, Lesson 4, all about rational expressions. So here's what we're going to do in this particular video, or more importantly, in this particular lesson. We're going to simplify rational expressions, multiply rational expressions, and add rational expressions. So this is basically what we're going to do. I have two expressions here. They're rational because they're quotients. A rational expression is a quotient of two polynomials. We'll do more of that later, but this is again a review of an Algebra 2 topic, and I'll tell you what, this Algebra 2 topic can be pretty tough, so we're going to take our time through this lesson. And so here we're just simply reducing these two guys. Here, on these two, on example 2, it looks like we're multiplying these two fractions. I'm going to show you the appropriate method for multiplying these two fractions. And then we're going to end this lesson with adding two rational expressions. And I think the other part of this is going to be the same uh, idea of either simplifying, multiplying, or adding rational expressions. And before I do this, I'm going to back up a little bit, and I'm going to do this is going to be the preface to Unit 0, Lesson 4, and it's all about rational numbers. So rational expressions have x's in them, and rational numbers are just fractions. So the first thing we're going to do is reduce the following. And how do I reduce? So let's start with this guy right here, 12 over 28. How would I reduce that? Well, what I'm going to do is look for common factors. And if I have a common factor in the numerator and denominator, I'm going to cancel those because I can do that. So I see that these both 12 and 28 have a factor of 4. So 28 is 4 times 7, and 12 is 4 times 3. So now the 12 and the 28, pardon me, are gone. And we made those, better make that 7 a little bit more prominent there. Excuse me. And now, what we're going to do, I see I have a like factor of 4 and a like factor of 4 down here. And what I'm going to do is just cross those off. And so those are gone. And so what do I have left? I have 3 7ths left is all I have. So 12/28. And we could see that without, we probably could have seen that 12/28 is 3 7ths without doing the factoring. And if we could, that's okay. But when we get to the rational expressions, it might be a little bit harder to see. It will be a little bit harder to see. Okay, so let's do a little bit, another example about reducing fractions. And we have 60 and 18. Well, right away, we can tell right off the bat that 60 is 2 times 30. Let me get a different color here. 2 times 30, and 18 is 2 times 30, dude. 2 times 9, and now right away I can see that I can get these 2's out of there. They're gone. They factor away. 2 over 2 is 1. So now I have 30 over 9. And then I'm going to factor again, and I see that 9 is 3 times 3. So we're going to go right to red. This is 3 times 3, and 30 is 3 times 10. Okay, so now these are gone, and what I'm going to do is cancel this 3 and this 3. And then all I have left on top is this prime number 3. And 10 does not have a factor of 3. So this particular guy, 60 over 18, is going to be 10/3. And again, I may have been able to see that without doing this factoring and canceling, but when I get to rational expressions, it's going to be very hard to see. So let's multiply, and this is probably the biggest area of that I'm concerned about as an Algebra 2 teacher. I know this is pre-calculus, but I get students who do not really understand how to multiply rational expressions. And it's because of not really incorrect lesson on multiplying fractions by the earlier teachers, but there's a specific way that we want to multiply rational expressions, be them numbers or be them with algebraic expressions. So we don't want to, a lot of people would say, hey, just multiply the 12 times 28 and the 49 by 18 and then go up here and reduce. We don't want to do that. What we want to do is factor everything and cancel like factors over here. Okay, so let's see here. I know 49 only has two factors. It's 7 times 7. And do either of these? Yep. Right here, this 28 is 4 times 7. So let's just kind of, bam, those guys are gone. And what do I have? I can cancel these 7s. So the 7s are gone. And so now what do I have left? I have a 7 on the bottom and 18. Let's see here. Oh, 12 and 18 both have a factor of 3. So let's factor 12. 3 times 4. And let's factor 18 is going to be 3 times 6. Now these guys are gone. Bam, bam. And what can I do? I can cancel these 3s. They become 1. So all I have left on top now is 4 times 4 and 6. But if I notice very carefully, and this is a good problem, and I admit this kind of gets messy, so you have to be very careful. 6 is 2 times 3. And you can cancel, get a 2 out of either one of those. Let's do a different color here because the red is conflicting up there. 4 is 2 times 2, so we can get that rid of that 4. And so look what we can do. We have another 2 here and a 2 here. They're gone. So then all I have left, so I have a prime number, and I don't have any other factors of 3 up here. So I have 4 times 2 is 8. And I have 8, 7 times 3 is 21. And so who would have thought that 12 over 49 times 28 over 18 was equal to 8 over 21, and it is. And not only is it 8 over 21, I know for a fact that this guy here is reduced already because I canceled all of the like factors. This is messy, and this is one of the reasons. This is certainly very messy. And this is one of the reasons why Algebra 1 teachers and pre-algebra messy. Messy. This is messy. Absolutely messy right here. But still the appropriate process to do this. And this is why you maybe didn't learn about factoring and cancel, because it is messy. But it's important for rational expressions. Last thing we're going to do here is add the following. And so if I add two fractions, one of the things that I remember from 4th grade or 5th grade, whenever you learn that, or 6th grade, you have to have common denominators. And the best thing to do is come up with the least common denominator. And some people call that the least common multiple. I want to call the least common multiple of 4 and 6. Or some people call it the least common denominator of 4 and 6, because I want the denominator. Okay, and we can easily see that, and it's going to be easy with algebraic expressions, so I'm not going to go over the real way to find the least common denominator, but we can see that you could go 4 times 6, but actually the least is going to be 12. And 12 is a multiple of 4 and multiple of 6, and it's the least common multiple of both of those. So that's the denominator that I'm going to use over here is going to be 12. So I'm going to write both of these expressions with 12. I'm essence going to change the value, not going to change the value. I'm going to change the way that 3/4 looks. I'm going to change the way that 1/6 looks. Okay, I'm going to put 3/4 over 12. What do? I have to multiply that by 1 in what form? I'm going to multiply this by 3 over 3, because 4 times 3 is 12. And I have to do 3 over 3 because that's 1. And I use that property of real numbers. A times 1 is A. So I'm going to multiply 3/4 times 3 over 3. And what do I get? I get 9/12. All right. And you don't want to reduce because you want to change. You want to do the opposite of reducing. You want to expand it so we get common denominators here. And what do I multiply? 6. 6 times what is 12? It's 2. So I'm going to multiply this rascal, not by 2, but 2 over 2, which again is 1. And what do I have? then this is going to become 2/12. And now I can easily add those. This is 11/12. 9 plus 2 over 12. So that's a very quick review over several lessons at the junior high or elementary level, all about rational numbers. Reducing it. Keep in mind you can pause the video whenever you need be. Reducing, multiplying, and adding. So let's get into our lesson then. Reducing the following. Well, what are we going to need to do? If we're going to reduce, we need to factor. We need to factor and cancel like. And if you recall, lesson 3 was all about factoring. So this is a factor. The top is going to be easy to factor. The top is going to be, it's a difference of squares. It's going to be x minus 5 and x plus 5. What we need to do then is factor this bottom down here. And I can see always the first thing you want to do is factor out. If you have a common factor of all, factor that bad boy out. And we see that all 3 of these terms have a 2. So I'm going to factor 2 out. Minus 4x minus 5. And I can see, hopefully, AC is negative 5. 2 numbers multiply together, negative 5, to add up to negative 4 is going to be negative 5 and 1. So I really don't need to do that factor by grouping. I can just write that as x minus 5, x plus 1. And if you need to review this, this is the previous lesson going from here to here. That's the factorization of the bottom, so I'm going to write that up here. It's going to be 2 times x minus 5 times x plus 1. And now I'm going to cancel like factors. You can cancel factors, not add-ins, i.e. you cancel factors that are being multiplied. Well, right here you go. This x minus 5 and this x minus 5 cancel, and there are no other common factors top and bottom. So then this guy here produces this. I just have an x plus 5 on the top, and I have a 2 times x plus 1 on the bottom, and there you go. Now that guy is reduced. Okay. Now let's go to the example, or the second example of example 1, this guy right here. So this appears to be fairly straightforward. So I think I can factor a common, just factor an x out of both of those rascals, which is going to be 1 minus x. X times x is x. X times negative x is negative x squared. Nice. And again, I can see that this dude right here factors pretty easy, because 2 things that multiply together to negative 1 to add up to 1. This is going to be x plus 2 over x minus 1. Okay, and you can check the arithmetic there. I think it's pretty good right there. So now I have this. I have this rascal over x plus 2 over x minus 1. And there doesn't appear to be any common factors there. But if I look closely, if I factor a negative 1 out of this guy right here, if I factor a negative 1 out of that, look what's going to happen. And this is hard for a lot of human beings to see. So I'm going to come down here, and what I'm going to do is rewrite the top. This is going to be x, and I'm going to factor a negative 1 out of that rascal right there. And what would I have? I would have negative 1 plus x over x plus 2 times x minus 1. Well, you should be able to see that this negative x plus 1 right here is the same as x minus 1, because I could rewrite this rascal right here as to x minus 1. Negative 1 plus x, x minus 1. So these are the common factors. What do I have left then? I have x times negative 1, which is just simply negative x over x plus 2. That's a dandy, Lee. That is a dandy. And this might be a good thing to know. If I have this dude right here, d minus, oh, we'll just go a over a minus d. And that's kind of what I have here. D minus a minus d. That is equal to -1. So that might be good to put that in your tool belt right there. If you can't get it all, you have to do is factor out a -1. But a lot of people have a hard time seeing this guy right here, going from here to here. All right, let's go on to multiplying some fraction. Keep in mind, you can always pause the video. That's what's nice about these videos. Now I'm going to multiply, and if you recall about multiplying, what do I have to do? I have to have like, I factor and cancel, factor and cancel, factor and cancel. So let's factor some stuff. So this 3x plus 6, I'm just going to rewrite that. I'm going to factor a 3 out, and that's going to be x plus 2. Down here, well, I can factor it. 5x squared is simply 5 times x, if you will. And I'm multiplying this by x. And I'm going to factor the bottom. That's a difference of squares. We really need to be able to see that. That's x minus 2 times x plus 2. And now, as I did with rational numbers, I cancel like factors. So look, do I have an x plus 2 on the bottom? You bet I do. Here's my x plus 2. Here's my x plus 2. I do have a factor of x. So those are gone. What do I have left on top? All I have left on top is this guy right here. I have 3 is all left on top. What do I have left on bottom? I have 5x times x minus 2. And that's it. That's this guy. I cannot reduce anymore. And that's the product of these two fractions right there. That's the product. Oh, now I have a little bit tougher rascal right here. It looks to be tough, but I think we can do it, this rascal right here. So we have lots of things to factor here. We can factor this top here, and we can see that that's going to be x plus 3 times x minus 2. 3 times -2 is -6. 3 plus -2 is 1. This guy here, I think we factored that earlier. This is going to be x, well, I think it was similar to that. This is going to be x plus 5 times x minus 1. 5 times -1 is -5. 5 plus -1 is 4. Times, this guy is your difference of squares, x minus 5 times x plus 5. Well, I don't know what happened to that 5. That kind of got wild there. X plus 5. And what does that bottom thing factor? Oh, let's see here. This is going to factor to x. Two things multiplied together to -15 to add up to 2. I think that's going to be x plus 5 times x minus 3. 5 times -3 is -15. 5 plus -3 is 2. So now I have everything factored. Now it's just a matter of canceling like factors. Do I have an x plus 3 on the bottom? Nope. He's going to stay. Do I have an x minus 2 on the bottom? Nope. He's going to stay. Do I have an x minus 5 on the bottom? Nope. He's going to stay. Oh, do I have an x plus 5 on the bottom? I do. I can factor this guy or cancel this guy and this guy. And those are the only like factors that I have. So this guy is going, and we're going to leave it multiplied out. It's going to be x plus 3, x minus 2, x minus 5, over x plus 5, x minus 1, and x plus x minus 3. And that's this thing reduced. That is the product of these two big giant rational expressions, is this guy right here. reduced. Okay, we're going to do a couple more easy examples. We may have to continue this lesson on another video. So, and keep in mind, you can always pause the video. So now we're going to add or subtract these rational expressions. And we notice here, we already have like denominators. So all I'm going to do, once I add those, the denominator is going to be x minus 3. All I need to do now is add the numerators. Well, x plus 2x is 3x. 1 plus negative 2 is negative 2. And bam, boom, done, added. And now I have to, in order to add these, I have to have the least common multiple, or the least common denominator, whatever you want to call it, of 5 and x minus 3. 5 and x minus 3. Well, these are both prime, so the least common multiple will be 5 times x minus 3, so that's going to be my denominator. 5 times x minus 3. Keep in mind, I'm going to add this, x minus 3. So how do I get to 5? How do I make 5 of 5 times x minus 3? I'm going to have to multiply the top and bottom of this guy to x minus 3. Because this is my 1, x minus 3, dude, not x minus 1. This is my 1 right here. And so I'm going to multiply 1 times x plus 1 over 5. And I'm not going to multiply out the denominator. I'm going to leave it like that. But now I have this, x minus 3 times x plus 1. Do some simple multiplication. And that's going to be x squared. Well, it's going to be 1x minus 3x is negative 2x minus 3. And that's what these two binomials multiplied together is. Now I have to change the x minus 3. I have to change this dude right here to a 5 times x minus 3. What am I going to multiply to? A 1 in the form of 5 over 5. So I'm going to multiply this guy by 5 over 5. I'm not going to multiply out the bottom. It's just going to leave it like that. But if I multiply out the top, I can't forget to multiply 5 to both terms using the distributive property. So this is going to be 10x minus 15. Give me a little space down here. Come back up. Okay. So now what's my denominator? My denominator is going to be 5 times x minus 3. I'm going to leave him b. And I'm going to add all the like terms on the top. I only have an x squared. I have a negative 2x plus 10x is plus 8x. And I have negative 3 minus 15 is negative 18. And that's what the sum of these two fractions, if I add these two fractions right here, what do I get? I get this dude right here. Okay. So we're going to close that part of Unit 0, Lesson 4, and come back and get the rest of it on another video. All right. We will see you soon.